I feel it blessed, rose for Christ. You gotta come, remember in class, we don't chew gum. Get off your phone and pay attention, not to mention you're your detention.
Hey stats lovers, this is your favorite math teacher, Mr. Ng. Let's go over the Chapter 4 test taken on April 27th. Carl wants some ice cream. The probability that he'll get the following flavors are chocolate chip, caramel critters, and blueberry cheesecake. Order the ice cream flavors according to the chance of probability from least or small to big. And you kind of just drag these around. So I think decimals is the easiest one. So to change a percent to a decimal, you just move it over. So this would be 0.55, 0.25. And then this one you can just say multiply by 20. So you get 20 over 100, which gives you 0.20. So the smallest one would be the blueberry, and then chocolate chip, and then caramel critters. Question number 2, the probability of picking a green. Question number 3, from a pack of cards, so there's 52 cards in there, determine the probability of each event mentioned in the first column and write its corresponding probability as a decimal round to the nearest hundredth. Hundredth means basically you have to look at this pink spot to help you determine that one. Okay, so there are 4 kings. There are spades, that's my spade, clubs, hearts, and diamonds. And there are 4 of them, so that would be 4 out of 52, which would give me 1 out of 13. And if I put that into my calculator that I have right in front of me, 1 divided by 13, 0.0769. So this would be, we're going to round up because this is 5 or higher, so this would be 0.08. Okay, for spade, the 4 suits, so there's 13 cards that are spades, and this will represent 1/4, which would give you 0.25. And then the last one, a red card. So red cards are hearts and diamonds, so there are 26 out of 52, and that represents half, so that would be 0.50. Question number 4, the following table represents a frequency, so frequency just means count. The last week's sales of bed in a store. Use the observed frequencies in the second column to create a probability model in the third column. Input it as fractions or decimals round to the nearest hundred. Okay, so you're just adding all these together, and then you would get 49. So the probability of getting a twin bed is 12 out of 49. Double is a 37 out of 49, and then 1 out of 49. And of course you can always add all of these together, so you get 49 over 49, which gives you a probability of 100%. Double check this one. Alright, that problem wasn't in there. Okay, number alright, we got the marbles here. Alright, let's go over this question here. This one's about the marbles, and it says select a marble without looking and putting it back. So you take a marble without looking in the bag, and you put it back. So this is a big idea because this is called replacement. And this also tells you that these events are independent. It's not working right now. There it is. Kind of. Oh, I know. There's a bug. So independent. That means when you pick the next marble, it doesn't affect the other. What is the best prediction possible for the number of times you will pick a marble that is not purple? Okay, so it doesn't really matter that you're doing this 10 times. Just the first time, because remember, if you keep putting the marble back, it kind of moves everything back to the original probability. So what is it that's not purple? Well, there are 3 purples. Yes, purple, no purple. That means there are 1, 2, 3, 4, 5, 6, 7. And so the probability you get no purple is 7 out of the total. And our total is 10 marbles, so 7 out of 10. What is the best prediction possible number of times you will pick a marble that is not a purple? So the answer there is 7. Alright, let's go on to the next question. Alright, using the following figure in order, pick a card, so that's 1 card, and a number, so 1. So this is where I'm talking about using those spaces. So picking a card, there are 3 letters, right? And then the marble. There are 1, 2, 3, 4, 5. So 3 times 5 gives us 15. There are 15 different outcomes that we can choose from. Okay. This question, an event with probability 3/4 is more likely to happen than an event with 4/5. More likely means it is greater. Well, the student who doesn't know their fractions, they're probably going to pick 3 is smaller than 4. But if you actually turn this into a decimal, you realize that 4/5 is greater. So the question is 0.75 greater than 0.80? This would be false. So the answer for this one is going to be false. Alright, which describes independent events, right? You know, I talked to a lot of teenagers, high schoolers, and what do you guys want? You guys want to be independent from your parents, right? Whatever your parents do doesn't affect what you do. Now, it's telling you disjoint events, which basically means another way for saying mutually exclusive. They're not related. And then it says select all that apply. If that contains red, green, and blue marbles, you randomly draw 2 marbles at the same time. I want to know the probability that either is red. So if I pick whatever it says, you know, if I pick the first one, you know, let's just say there's 10 marbles and then 5 red, that'll be 5 out of 10. But if I'm picking 2, that means the next time, let's just say the first one was a red, that means I have a smaller chance because, or the probability is affected because there's 1 less marble in there. So this one is dependent, right? It's dependent on the first pick and affects the second one. B, you roll a number cube and spin a spinner. You want to know the probability of rolling a 4 and spinning a 7. Well, the cube and the spinner are not attached. So these are independent events. So this is one of them. C, lunch includes your choice of a salad and your choice of vegetables. You want to know the probability of choosing a house salad and a broccoli as your vegetable. So think of it as like 2 separate dishes. You have all the salads. You randomly pick one out of your fridge, and you randomly pick a vegetable that's not a salad. Okay, that's the hard part. I'll just make sure that's clear. But they're independent. Kind of think of it as, I don't know, sometimes there's glue on things. So you can imagine the vegetable is glued to the salad container. That's how it's affected. But these are not. They're independent. Okay, and D, a math class has 25 students. The teacher randomly chooses 2 students. You want to know the probability that one of the 2 students will be a female. Well, if you choose one, and let's just say there are 12 females in the class, the first probability is 12 out of 25. But once you pick that person, you can't pick the same person. So you'll notice that my numbers here are not the same. So it can't be D. Answers are B and C. Alright, for mutually exclusive events, A and B, this means kind of like in the Venn diagram world, the circles don't overlap. So the probability A is 5 over 10, and probability B is 1 over 10. What is the probability that either event A or B occurs? So they want the probability of A plus the probability of B. So all you have to do is substitute them in there. They have no overlap. No overlap. So that means you're not subtracting. No subtraction. You're not subtracting a double count. Does that make sense? So B is our correct answer. Alright, let's take a look at this next table here. Consider the data in the table below. We have right-handed, left-handed. What is the probability that any such person is male, given that they are left-handed? So probability that they're male, given that the person is left-handed. Okay, so this condition here is first. So we're going to find the probability of they are left-handed, for all those people. And then given in that portion, what's the probability that person is male? Okay, so probability that they are left-handed, so we just need to add up all of these. So this would be 24. I don't know, I'm just going to add all these up. So 100 males, 100 females, and a lot of right-handed people. 160, 176. Okay, if you add those two together, you get 200. So it's 200 people total, but we're looking just at the condition given that they're left-handed. So here is left-handed. How many left-handed people do we have? We have 24 left-handed people. Now, this is saying now, given in the left-handed, given that they are left-handed, what's the probability in the red box that they are male? Well, that's only this number, right? That would be 13. So 13 out of 24, which means it is B. Alright, take a look at the spinner here. Jerry spins the spinner once. What is the probability that it is a 3? So the probability that it's a 3. Or, which means we're adding, and then probability of an odd. Okay, so let's look at all the odd numbers. 3 and 5 are odd numbers. So probability of 3 plus the probability it's a 3 or a 5. Okay? So you'll notice probability of 3 is 1 out of 4. And probability of 3 out of 5 is, there's 2 numbers. Okay, but you'll notice that we did what? We're counting the number 3 twice. You guys see that? So we actually have to subtract the double counting. In that case, that would be the probability of 3 because it's counted twice, so that's 1/4. So fractions, 1 plus 2 is 3 minus 1 gives me 2, 2/4, and 2/4 reduced is just 1/2. 1/2 is our answer. Okay, let's see if we got the next one. Let's get this problem. Alright. The Venn diagram shows a distribution of students who take Spanish and or French. Represent the data in the Venn diagram as a two-way frequency table by dragging the correct values into the table. Okay, I'm just going to try to replicate this so I don't have to keep scrolling down. Spanish. I like to say taking Spanish, no Spanish. So I'll just call it yes Spanish, no Spanish. Then we have French. Yes French, no French. Okay, let's talk about taking Spanish. So Spanish and no Spanish. So in this first box, it's both yes Spanish and yes French. And that's going to be this 2 here. This 2 means the students are both saying yes to Spanish and taking French. So this would be 2. Okay, so yes Spanish and no French. So yes to Spanish, but no French. This would be a 4. And so the total amount in the whole red circle is 2 plus 4 is 6. There's a total of 6 people taking Spanish. Okay, no Spanish, but yes to French. So this person is taking French only. This is a 9. Try to get more colors here. And then no to Spanish and no to French would be these 5 people outside of the circle. So 9 plus 5 is 14, and you can just add up going across, and you'll notice that the numbers going this direction and this direction represent the total. Okay, so that's my total there. And that's how you would fill it out. There's no questions associated with it.
Mathematics includes the study of quantity, structure, space, and change. Math can be so complex it could be considered strange. So strange equations could be rearranged. Don't even get me started on fractions. To multiply them, it's going to take a lot of action. But math can be simple. All it takes is practice. Your brain is like a muscle. Make sure it's active.